Welcome to SpoolValve. In this tutorial, I'll show you how to extract and cut the fluid volume of a spool valve. The resulting STL surfaces will then be exported to PumpLinx and meshed with a push of a button. This new feature in SpaceClaim provides a natural and seamless continuation of the model generation process using PumpLinx. In order for you to get an idea of where we're going and how we'll get there, let me describe briefly what the objective is. In SpaceClaim, we will have STL surfaces of a spool valve, and we will prepare the surfaces for use in Cimerix. So we'll prepare the surfaces in SpaceClaim and export and grid them automatically after we launch Cimerix from SpaceClaim. We will then apply boundary conditions in later tutorials and run it and post-process it. So that's the objective. The first step is to extract the fluid volume. This is the housing for the spool valve, and we're interested in the interior surfaces or the fluid volume. This is the spindle, and it will be allowed to move back and forth along the Z direction where a high pressure fluid enters the valve and presses against the lower face of this valve, pushing it to the right. There's a spring that's not seen in this chamber that resists. So the position of this valve spindle is determined by the force balance between the spring and the pressure forces due to the fluid. As this spindle moves up, the fluid is allowed to flow through this to the low pressure side and then exit out this outlet. So we first extract this volume in SpaceClaim. Then the next step is to split the fluid volumes. The reason why we have to split this is because of the motion of the spindle. These volumes will be expanded and compressed. So once we split them, we'll have this is a separate volume which can be compressed or expanded, and this and this. These are annular volumes which can accordion as this spindle travels back and forth. The spool travels back and forth. The next place we have to cut this is here and here, so that we end up with volumes here and here. These are expandable and compressible. This is a rigid fluid volume. This and this are also expandable regions. Then once we apply boundary conditions and run it, and you can output all sorts of data here, and in the end, after post-processing, then you get an animation which shows you the results. Here are the CAD surfaces of the spool valve as seen in SpaceClaim. Now we'll extract the fluid volume. Go to Volume Extract. Pick the surfaces that surround the inlet and outlet, and pick an interior surface to seed. And here we have the fluid volume. So I'll temporarily turn off the CAD surfaces. I'm going to take an X cut of this so we can see what's inside. And there's the X cut. And now we're going to split this volume. Since the spindle will be moving back and forth in the Z direction, these surfaces here will be sliding along here, and these volumes have to be allowed to contract. So we'll have to split it along here, a projection of the spindle diameter across here, the largest diameter. We'll split it all the way down. So we go into Split Body, select the body, select this piece here. This is the spindle outer diameter, and we can see it cut along here and here. So now we have this volume here for compression and expansion, and also here and here. We'll need to split it here and here as well to isolate these areas here. We'll select the little annular region, and on the other side as well. And now we have all our cuts that we need. Now in SpaceClaim, you can also name surfaces so that when they're imported into PumpLinx, they won't have to be split off. Because if you tag it in SpaceClaim, then it automatically knows to keep that surface. For example, this surface here, this is an outlet. And if we go into 3D, we can select that and then name it as outlet. And now we won't have to split this surface off here in PumpLinx, because it will have come in as a separate STL surface. That's one advantage of naming it all in SpaceClaim. It's a lot less splitting and recombining operations I have to perform if you do all the naming in SpaceClaim first. Let's name our volumes. All of these volumes will be named. I'll just name one just to show you how it's done. just left click on it and then right click and then highlight rename. And this happens to be the low pressure chamber. If we skip ahead to a version that already has all the renaming done. So this is all the named volumes. And one other thing you can do in Space Claim is to control the mesh size. You have the cell size on the surface and the maximum cell size that you can control. So you can refine or unrefine picked surfaces. So now let's launch Numerics and Mesh. Here's our model in PumpLinx. Here are the CAD surfaces. We don't need these anymore unless we were going to do some remeshing in PumpLinx. But in this case, we don't need to. So I'll just put that away. And here are the corresponding volumes. Each one has boundaries associated with it, which later we'll all have to rename if we decide to split this up any further and remesh it. But in this case, our mesh is good. Let's take a look at the mesh, create a cross section. And this is a good grid. So now we're ready to apply boundary conditions, which we'll do in a later tutorial. In conclusion, I showed how to extract the fluid volume, how to cut it along sliding planes, and how to rename the different volumes. Then I showed how to launch Numerics and import the CAD surfaces into PumpLinx and mesh it automatically.